Hello, everyone. Welcome to the DSS Summit and welcome to the talk about multi-region applications that are designed to function across distant data centers, locations, and cloud regions. This talk is going to be about YugabyteDB for sure, but also about Google Cloud Platform and various components of GCP that help you to build those types of applications. So that's why we have a special guest today, Akshay Ram, who is going to help us in this discussion. How are you doing, Akshay, today?
Hey Dennis, doing great. Hello everyone, my name is Akshay. I'm a product manager with GKE and Google Cloud. Happy to be here. I look forward to this discussion.
Excellent, excellent. Then let's move forward. So first, folks, what are the multi-region applications? I think that we all understand what multi-region applications are, but the first question is, why do we need them? If we imagine those types of apps, those application instances need to be deployed across distant locations. And those distant locations can be, let's say, several cloud regions within the United States or within Singapore, or it can be application instances spanning across countries and continents, like on this picture. But the question is, why do we need those types of applications? And primarily, there are three reasons. The first one, you do this for high availability, because if any data center goes down, your application will not be impacted if there is another instance that is deployed in another location. Second reason is performance. Take a look at this picture. Let's say that you have application that is serving users across the planet, and you want all of them to have the same user experience. You want them to have the same low latency regardless of their location. So that's the second reason for deploying multi-region applications. And the last one is compliance. Many countries that you see on this map require you to store customer data in the country of their residency. GDPR, different laws by the Reserve Bank of India, and many other examples out there. So overall, you create those multi-region applications for the cases when those application instances needs to be deployed across several locations for high availability, performance, and compliance. But this example can be extreme, and like most of us start with much simpler configuration when you deploy your application that is not running across the planet, which means that also multi-region applications are widely used when you run across multiple data centers that are in a relatively close proximity to each other. For instance, you have some application that is primarily focused on the United States market right now, and that's why you deploy the application instances across the West, Central, and East regions in your cloud environment. So let's now see how to build multi-region applications in Google Cloud Platform. And the mic to you, Akshay.
Yeah, thanks Dennis. So I think the first consideration for Kubernetes customers is usually the cluster is the boundary. And every GKE or Google Kubernetes Engine's cluster is regional. And a lot of customers with Google Kubernetes Engine, you get to scale up to 15K nodes, which is industry leading. So a cluster has plenty of scale and availability for a lot of our customers. But as Dennis laid out here, there's some customers who don't just want regional based clusters. They want multi-region Kubernetes clusters. And for reasons such as latency, compliance, and some sort of disaster recovery scenarios. So what we see a lot of a common pattern is we built Kubernetes to be multi-cluster capable. We use something called multi-cluster service ingress, which uses the global load balancer underneath the hood. GCP has a global load balancer where you can load balance traffic across multiple GCP regions. So that is the foundational basis where we went from Kubernetes just being a cluster-based solution to a multi-cluster based solution and multi-cluster and multi-region, because we're built on the global load balancer. The slide specifically says Anthos global load balancer, but you can use multi-cluster ingress with standalone with GKE. Or if you're using GKE Enterprise and Anthos, you can also use it with that configuration. So basically what that boils down to is that there are four layers here. One is the ingress layer, which you want to have multi-cluster ingress through a global load balancer. Then, of course, your application itself. I don't think there's many changes here because you want your application to remain as consistent as possible, even within one cluster across regions. It should be the same code. You want it to be agnostic. Then, of course, GKE. So you can deploy your Kubernetes clusters across multiple regions. GKE supports all GCP regions, so you should just be able to deploy it. And finally, we see customers who want to store their data and not replicate it on the fly because that adds latency. So you want to have a database that can distribute the data globally. And that's the interesting angle where we see a Yugabyte being one of those angles here as well. Back to you, Dan.
Yeah, excellent. And also talking about Google Kubernetes Engine, it's obviously not the only one solution for multi-region applications in Google, right? You can deploy your applications in virtual machines. But the question is what the easiest way to approach multi-region applications. And that's, even from my experience, Google Kubernetes Engine, it's much easier to start with an approach in your multi-region setting. But yeah, virtual machines are also available, folks, if you like. So let's speak about the application layer, right? As Akshay said, that still the application remains pretty much the same, whether you deploy it in a multi-region configuration or single region. But our application for today, because we want to show you the demo, our application is a messenger. Many of us use Slack messenger these days, like it's a corporate messenger, and we decided to reinvent the wheel, but for a good purpose. We just want to show how you can run your messenger, such as Slack, across several distant locations, across multiple regions. But we have just a few microservices. We have the messenger microservice that comes with key messaging capabilities, such as send messages, create workspaces, create channels, etc. And that microservice uses YugabyteDB as a transactional database, because we have the user data, we have messages, we have everything that needs to be stored in a transactional database. Also, we have the second microservice called attachments, because our messenger allows you to upload pictures. And naturally, all those pictures needs to be stored in Google Cloud Storage, because that's an ideal solution that exists for this type of data. And finally, this is a Java application, and we use Spring Config Server just to share some configuration that is relevant for every messenger. And this configuration also can be specific for a concrete region, depending on your settings. This is, let's say, a single region configuration. We have some region A and we have some zone availability zone A. But the question is, how do we make this multi-region? And it's simple, folks. First step, you need to select your regions that are required based on your customer base. And here is we are talking about some region A, region B, and region C. Then in every region, provision dedicated Google Kubernetes Engine clusters. That's simple and very straightforward. Then inside of every Google Kubernetes Engine cluster, deploy your microservices, just the same microservice instances, no any differences, the same source code, the same binary code. And then make sure that your microservices are connected to the YugabyteDB and Google Cloud Storage that are designed to be global databases. And another important aspect is multi-cluster ingress, or Anthos. Like Anthos, we're talking about Anthos, but also it's basically multi-cluster ingress, as Akshay mentioned. Makes sense? Moving forward, let's talk about the specific steps, how we bring this architecture to life. Back to you, Akshay. Step number one.
So I think the first step is, of course, thanks, Dennis. I think the deploying Kubernetes clusters, as I said, should be pretty simple. Then the fun part here is you can stamp this out as infrastructure as code and just automated deployment across multiple regions. The application doesn't change, so you can keep the same container image. So this should be pretty simple to use. So you can choose 3 regions here in this specific demo. Next slide.
Yeah, and actually, if you want to do a quick pause, for instance, for our demo, we are going to use also 3 Kubernetes Engine clusters. Let me make it a little bit bigger. And here is these clusters. One of them is in the United States Central one, East one, and West one region. It's all simple. You just deploy them, and then you can use commands like gcloud container fleet membership list, and you are getting this. So our clusters are ready, but we'll start using them a little bit later. So heading back to you. Step number 2.
Yes. So the second step is obviously you need the global database. And I think here is where Yugabyte really fits in, because it can handle the regional cross-region replication automatically for you and make sure your data is as close to your compute, such that you have the low latency or the compliance scenarios that some of the earlier use cases that Dennis laid out.
Yeah, and speaking about multi-region databases, like even on this slide, we don't talk just about YugabyteDB, because we want to introduce you to the generic configuration for multi-region apps. It's just that YugabyteDB, we use YugabyteDB as a reference database, right, that is designed to function across those distant locations. But when it comes to YugabyteDB, let's take YugabyteDB as an example. When you approach multi-region configuration, here is what we usually recommend. We recommend 4 different deployment options, and you need to pick one of them because there is no any silver bullet. You need to decide, and the decision will be based on your specific application requests and requirements. For instance, on this slide, what we show, imagine that our primary customer base right now is in the United States. And we want to make sure that the latency is as low as possible for the customers from this country. That's why you can deploy a multi-region cluster in the United States and define one of those regions as a preferred one. A preferred region will be storing the primary copies of your records, which means that by default, all the user requests will go to that region. And there will be minimal communication between the primary region and secondary regions, only when you need to synchronize updates and inserts from the primary to the secondary ones. And this one is good. And also what's important to note, even though if you have a preferred region where all the writes will be handled, you can use their other regions for read requests. You can always load balance reads from other locations. And the next question, let's say that you went forward with that configuration. Your primary user base was in the United States, but then you are becoming the victim of your own success and your application becomes well known abroad. So what are the steps, right? How do we scale our solution? We can quickly go ahead and deploy our Kubernetes engine clusters in all of those places, but we also need to make something with the data. We need to deploy database instances. One of the easiest approaches is to attach read replicas, because usually when you're thinking about the scale, first we want to accelerate reads. That's the first step, because writes can be the second milestone. So with the reads, many databases, it's just a generic approach, including YugabyteDB support read replicas. You can attach read replica nodes to your primary cluster, and then your customers from other locations will be enjoying much better latencies. The only one caveat here, those read replicas receiving updates from the primary cluster asynchronously. All the synchronization within the primary cluster is synchronous, but between primary nodes and the replicas, it's asynchronous. So there might be some data lag. Another one, let's say then you fixed everything with read replicas, but then you understand that now, folks, we are running it globally, we are used globally, and we want to have low latency, and we want to have fault tolerance across all of those locations for both reads and writes. And another approach that is used by and supported by many other databases these days is to use multiple standalone clusters. So you can deploy a standalone cluster in the United States, in Asia of YugabyteDB. If needed, you can enable asynchronous replication between them. But if you go forward with this deployment option, it's highly likely that those clusters will be pretty much isolated. Because if you decide just that your application needs to pull data from one location to another location, then you would be required to join this data, to merge this data on your application layer, or you would be required to use some other third-party solution. And another configuration, the last one that is ideal if you want to accelerate both reads and writes, if you want to have low latency for write and read requests across distant locations, is a geo-partition cluster. This one is uniquely supported by YugabyteDB. So basically what you need to do, you deploy a single cluster across your selected regions, and then you define a special column. We call this a geo-partition column. And based on the value of this column, the database will place your records to specific nodes, database nodes. For instance, if the name of this column can be random. In this example, the column name is region. So when you're inserting or requesting data, and if the region name is European Union, then the database will automatically write this data or read this data from the nodes that are deployed in Europe. So this is what the database does. And that's it for now. If you want to learn more about multi-region deployments of YugabyteDB best practices, etc., just take a screenshot and go to the recordings of this YugabyteDB Tech Talks. Back to you, my friend. Let's talk about step number 3 and step number 4, and then go forward with the demo.
Yeah, so I think once you have set up the policies, you've deployed your Kubernetes clusters, you've deployed the database, and you use one of the policies that meets your requirements as Dennis laid out. Either you want to have a single read and I'm single write, multiple reads, or a geo-partition clusters, or completely unique isolated clusters with async replication. You have to then deploy your application containers. This is actually the easiest step because now you have set up a lot of the nuances of how to replicate your data. This can be as simple as just deploying a Terraform script or just using the gcloud command, depends on what you used for your deployments. And you can deploy your app across the clusters of your choice. Next slide, Dennis. And then obviously now that you have your application set up, your database set up, your Kubernetes clusters as your base platform in each region, you want to set up multi-cluster ingress. As I said, multi-cluster ingress is available on GKE Enterprise, which is also known as Anthos. And it's based on the global load balancer. So you can set up rules such as affinity to a region, or you can, by default, any request that is coming from a particular region is mapped to the application that's closest in the region. For example, if you have traffic from North America, you get routed automatically to the North American application. So there's a lot of the intelligence built in, and it's the key infrastructure component that allows your clusters to really operate in this geo-distributed manner.
Let's go to the demo. So on our slides, we were using an example for the messenger that is deployed across several countries. But for the demo, we will deploy a multi-region cluster and solution in the United States. Because let's say our messenger right now is still very small and we are focused on the United States. Let's see how it works. Switching back to my console. You already know that we have 3 clusters running in the United States: Central one, East one, and West one. Presently, my kubectl tool is looking at the East one location. So let's see if we have any application instances there. For that, we need to do get deployments. No, we don't have anything. Let's deploy it. As actually I mentioned that the deployment, once you have the clusters ready, the deployment is a breeze. I have a special batch script, but what actually it does, it will be building and deploying several microservices. Remember, we have 3 microservices. We have the Spring config server. It's deployed. We have the attachment service, and we have the messenger service. Those 3 represent our application. So let's check. They're already up and running. Where are they running? They're running in the United States East Coast. So let's connect to the messenger microservice and check the logs. I want to see the logs. Okay, looks like it's connected. Yeah, it's connected to our database. Where does the database live? Let me go and show you the database. I lost in my, yeah, here it is. So I'm using for this one is a YugabyteDB cluster spanning across 3 regions in the United States: US East 4, 1, and Central 1. I have read replicas, but we are not going to use them in this example. The cluster is running and the application has successfully connected. Now, let's test this application. For that, I first want to get connected using their external load balancer. Not the global load balancer, not the multi-cluster ingress, but this load balancer that is specifically created for this cluster, for this application instance. That's the IP address. I need just to do it this way. All right. That's our messenger UI. And here, as you can see to the left, that there are some logs. So generally, we connected. That's one of the chat. We have several workspaces, like in Slack. We have different channels with unrecognizable names. But let's say hello, test. And you can see that the data is sent to the United States. And right now, the latency from the application instance to the database is around 70 milliseconds for the writes, because every message needs to be replicated across several regions, like United States East, Central, and East 1, East 4, and Central. That's why. Next, let's do this, because what I want to do, we want to use multi-cluster ingress. For the multi-cluster ingress, it's also deployed and available. So that's the command. You can use kubectl to describe, and you can get this multi-cluster ingress. That's the name of my ingress. And VIP stands for, not for the very important person, but for virtual IP address. So it's already ready. Let's do this. Let's go back to the browser. Let me actually close the slides, because the slides make things a little bit distracting. All right, so now I'm going to use this IP address. This is the IP address of the multi-cluster ingress. That there is another attempt to connect to the application, and that's another session. But the multi-cluster ingress will be forwarding all my requests to this application instance automatically. So that's the point. One IP address that decides which instance is going to handle my requests. All right, MCI request. Let's do some sense, test, and test. So generally, wonderful. So we have this IP address. So now let's do this. I will give this IP address of the multi-cluster ingress to Akshay. So Akshay, let me go to the comments in there. No, I cannot share the comments. Let me do it here. Check the studio. So there you will see the IP address.
Yes, I have it.
Okay. And now what I'm going to wait, I want to see some message from you in here, and I want to see some logs. Okay, we see the logs. Wonderful. So it means that Akshay has successfully connected. So there is no any auto refresh. What channel are you typing into?
Principal Financial Group, I think. That's the workspace.
And the first one, right?
Yeah.
Okay, I see this. Hi, Dennis. Wonderful. Yeah. And what's cool about this, Akshay is based off Seattle, the West Coast. I'm based off Tampa, Florida, the East Coast. And right now, yeah, we use this single IP address of the multi-cluster ingress, and it forwards all of our requests to the application instance. We have only one application instance, and that's the problem. Ideally, we need to have a dedicated application instance for Akshay, who lives in the West Coast. We don't want his request to travel through the country to the East Coast. How do we do this? Easy. Let's deploy this application instance in the West Coast, in GKE. So I'm opening another window. So right now, as you remember, my kubectl tool is looking into the United States East cluster. I want to switch the context to the West. All right, we switch to the West. And next, I'm going to deploy the same identical application instance, but in the United States West 1 region. No, not that quick. First, I need to go to my application folder where all the scripts are located. And after that, we are deploying this to the West. So once we deploy this to the West, then our assumption and our hope that multi-cluster ingress will automatically forward requests by Akshay to this application instance, to the West, not to the East. That's the purpose of having multi-cluster ingress. All right. Looks like it's ready. Let's check this.
You want me to send you a message, Dennis?
Not yet, man. Let me open the logs. Yeah, sure. I want to open the logs for this instance. Okay, yeah, the instance connected. Yeah, it's still being connected. Yeah, it's going to be ready. All right, the instance is ready. So let me do this. Waiting. Send some message, Akshay, please.
Yep. Just give me a second. Sent.
I don't see any logs here. Try one more time. For some reason, it's still redirecting you to their...
Yeah, I think I had to re-log in, that's all. Because I was logged into the old one. I think the session was expired.
Okay, now we see the logs. Yeah, the session now has expired.
Yes.
Send one more hello message from Seattle. All right, folks, you can see here, yep, the traffic in this logs means that Akshay has been forwarded by the multi-cluster ingress to this application instance. Why the latency is high? Because we are not using a geo-partition cluster of YugabyteDB right now. We're just using this cluster with the nodes in United States East and Central, and the node in East 4 is the preferred one, meaning that all the write requests need to go here first. But generally, if you want to see how to deploy across multiple regions with low latency for all of the locations, you would need to join this session. This session is also happening today. This is a workshop. And during this workshop, we will continue our conversation about multi-region deployments, but with the focus on low latency. Wonderful. So let me do this one more time. We already see that everything works for Akshay. And hello from, let me do hello from Tampa. And you can see that in my case, my request keep being sent to the East Coast. This is what I want to have. But now let's emulate some outage. Right now, imagine that there are some issues in the United States East region, and I want to keep using this messenger. So let's do this first. Let me switch to this context, the United States East. And after that, yeah, I want to delete this application instance. So here, as you can see, that the application instance is no longer running. And that was the IP address for that application instance, so the instance is down. But we have multi-cluster ingress, we have antas. So if I start typing here, you can see that the multi-cluster ingress detected. That instance is no longer available. And I was forwarded somewhere else. Where was I forwarded? Obviously, I had to be forwarded to this application instance in the West Coast. Let's check this. Wonderful. You can see the logs in the East. All right, outage. But we are up and running. So this is how it works. Even during the outage, you don't need to be bothered about anything. You just need to make sure that you have multiple application instances, that you have multiple Kubernetes clusters, and then just keep connecting, keep being connected to the multi-cluster ingress IP address, and the ingress will make sure that the traffic is forwarded to the nearest and to the healthiest application instance. How do you like that, Akshay?
That's super cool. As I was saying, the fact that you can have an outage and no downtime to your users is phenomenal. An entire region outage, this is not just a zone. So yeah, if there's God forbid, a hurricane or any of that, you are still protected from your users should be able to chat.
Exactly. And generally, as a quick summary, folks, the beauty of public cloud environments like Google Cloud Platform is that the environment comes with abundant resources. You can pretty much deploy your application instances in every region to withstand outages, to deal with low latencies, and comply with data regulatory requirements.
Yeah, I think the closing thoughts is the cloud has, as Dennis said, evolved in really powerful ways, where a lot of the undifferentiated heavy lifting you would have to do to set up and maintain a global load balancer, a global database, is now vended as managed services, such as Yugabyte and the multi-cluster ingress piece for your Kubernetes. So what it allows you as users is to really benefit out of the box and pass on all of that complexity and SLA of handling all of these nuances of regional balancing, load balancing to your cloud provider or your database vendor, so that you can focus on your business logic. And just this demo shows you how powerful it is to have a regional, cross-region deployment with Kubernetes, with Yugabyte on GKE, and it enables you to iterate on your business really quickly, such that you can focus on your business and you leave the infrastructure to us.
Wonderful. So thanks for coming, and enjoy the rest of the conference, folks. And don't forget, if you want to learn more about multi-region deployments, but with the focus on low latency, come to this workshop later today. Bye-bye.
Bye.